Hello and welcome to TidyX episode 26. All right, episode 26, we're going to be covering more. This is the second episode of our Shiny mini-series in TidyX, and we're also going to go over a really cool submission, at least I thought it was a really cool submission for TidyTuesday from this past week. My name is Ellis Hughes. I am a statistical programmer, and you can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward, and I do data analysis and sport. You can find me on Twitter at OSPPatrick. You can find both of us on Twitter at Tidy_Explain, or you can reach both of us on Gmail at tidy.explain@gmail.com.
Yeah, we've actually received a few emails over the last several weeks, and so we will get back to you shortly. It's just been a little bit busy for both of us. Life is just a little bit insane right now. But we've seen your email, and we will get back to you. All right, so this week's TidyTuesday Dataset is on global crop yields. So it's from Our World in Data, so they're a great source for looking at ways people can visualize data as well as just a source of data itself. I believe we've used, or TidyTuesday has used Our World in Data in the past, and I'm sure it'll continue to be used in the future because it's a super rich resource for data sets and ways to visualize it. And definitely go check out that website. They've got a really cool dashboard on how to do it. This week there were also really great visualizations, really artistic. David Robinson in his screencast created a Shiny Flexboard or Flex Dashboard. Was it Flex Dashboard? No, it was a
Flex Dashboard. Yeah, Shiny is embedded into the Flex Dashboard.
Yeah, so that was a really cool one to see as well. But the one that we picked this week to go through, I thought had some really cool pieces of code in it that I'm really looking forward to explaining. It was from the Twitter handle at Mr. Ochiwar. This is the plot that he generated. It's a line plot showing Nigerian crop yields of some key crops: cassava, cocoa, potatoes, rice, and wheat. It's a very clean plot. I really like the way it looks. And like I said, there's some really cool code in it that I'm looking forward to explaining. He posted his code as an image here through using the Carbon website there. It's a pretty cool way to show your data. But so we took that data and we transcribed it down into our studio session. So we're going to hop into that right now. All right. So here is the code that was in that image. We wrote it all down here for y'all so we can go through that, and this will be available on the TidyX GitHub as well. All right, so first he's loading a lot of libraries. TidyTuesday woo. Tidyverse, as always, to do your data manipulation. He's got some. This looks like his standard set of packages that he always loads when he's starting to do his data analysis and visualization, which is not a bad thing to be doing, because that way you just always know I'm going to have availability of these functions right when I get going. I don't have to remember. Oh shoot, if I want to bring in this library, I need to do this, or if I want to do this thing, I want to do this. So this is not a bad idea to have your standard set of packages that you like to load, especially if you're doing it fairly regularly. So let's load all those. We got some warnings just because I'm running a Windows machine. It's not a big deal. Then he goes and loads the data using the TidyTuesday R package using ttload. So we get the nice messages letting us know we're downloading it. You can then print it out. See the README right there in your R session. I think that's a feature that I really liked putting together. Then pulls out two data sets, and you do that with the $ notation out of the Tues data, the TT object. Out of there is pulling key crop yields and arable land out of that the data there. So we take a quick look at that. This data set is 13,000 rows. It's a pretty long data set and 14 columns wide. So it looks like it's the country code, what year the data is from, and then a bunch of crops by tons per hectare that they're pulling out there. So he goes through here. He creates this function here called shortener, and this piece will become really. I think it's a very short piece of code here, but it creates something really cool later on. So what this is doing is you pass a string into it, and it's going to use str extract, which is from the stringer package, and it's going to subset up to the first underscore. And it's going to subset that out of the data set there, and then it's going to convert it to upper using the toUpper function, which is a base R. So it's going to, if you pass it a string that has underscores in it, up to that first underscore, it'll pull it out, and then it'll turn all those letters to uppercase. And so that's what this function is doing. It's called shortener. Do that. So then he gets into the data manipulation here. Patrick, do you want to take us through this?
Yeah, sure. So the first thing that he wants to do, as we saw in the picture, it's a picture of Nigeria and the crop yields over time. So he's going to create this new data set that is specific to that country. In this case, it's called an entity. So from the key crop yields data set, he calls the janitor clean names function. The clean names function is just going to clean up, if you remember from the kind of the head of the key crops yield that we just ran, you saw a lot of parentheses and kind of like ugly looking columns. The clean names function from janitor is super easy because it's just going to kind of, get some underscores in the white spaces, get rid of the extra stuff there, put everything on lowercase. So it just makes it look nice, a bit easier to work with. And then, like I said, he's going to filter out Nigeria because that's what he wants his plot to be specific to. So now that he's got that, he's going to create a new data set. And this data set he calls P1, which is going to be specific to the plot. So he takes that Nigeria crop yields data set, and he's using the select function here. Instead of using select to include columns, he's using select to exclude columns. So the minus sign is basically indicating which columns he no longer wants in that data set. And then he pipes in pivot longer. So now he's got his data set, which is minus those columns above, and he's going to pivot longer in, so there we can see what that looks like. And you can see the column names look nice and much cleaner and easier to work with. So he's got this smaller data set that he's going to pivot longer. So right now it's in a wide format. So basically you have 1 year per row. He's going to spin that out so that it's going to be each year as well as a corresponding crop yield. So he does that by saying pivot longer columns, all columns except for the year column. So the year column is going to be the variable that gets repeated. So for example, right there at the bottom in row 10, we see 1970. That's going to be repeated n number of times for each type of crop that we have in the current wide format. So he takes every column except for year. He wants the names to be in this new column called crop productivity. So every name of those rows that are currently in that wide format are going to be deposited into this new column called crop productivity, and the values corresponding to those crops are going to be deposited into the tons per hectare column that he now creates. So that'll get him into a long format. So we're going wide to long. And then the mutate here, he uses, he's using mutate here to add or address some of the columns. So for example, year is a numeric. You can see it right there in the tibble as a double. He wants to make that a factor. So he does year pipe as dot factor. You could have just done as dot factor and put year inside of the parentheses. You would have got the same result and saved a little bit of code length, I guess you could say. Either way, it'll still work. And then crop productivity, he also wants to be as a factor. You can see in the tibble below there in the console, it's currently a character. So he's going to change both of those to factors. And now we have a P1 data set, which took our wide format data and spun it into a long format.
Yep.
That's pretty cool.
Yeah, there we go. So now we've got a data set that is following, tidy principles, where it's each row represents a single measurement, and this time it is year and what the crop is, and then the value is how much how many tons per hectare that get made. And so now he's going to hop into his plot, and here's the cool piece that we're about to cover that cool piece in a second here. So he takes P1, pipes it into your GG plot, and he sets the x-axis to be year. He set the y-axis to be tons per hectare, which is, of course, that numeric value there, and he sets group equals to 1. You need to do that because the geom line, it draws lines based on the groups that exist. So if for some reason he'd chosen multiple countries, this is where you define your multiple countries, but in this case there's only Nigeria, so he needs to set the group is equal to 1 so it knows that it's...
Yeah, and I think if he left the year as numeric instead of converting it to factor, I don't think he would have had that problem, actually.
Well, we can do a quick test there.
Let's take a look. I can't remember, but I feel like...
it's...
oh no, it'll work, but you have to run the full facet.
The full facet and whatnot. Let's leave his code as is. Because we're trusting what we want to reproduce his plot the way that he did. All right. So now he's got the geom line. Now he's got the geom point, which is going to be adding points to every measurement that we have there. So at the year and the tons per hectare, it's going to draw a point there. Then he's adding the labels there, so it doesn't want an x-axis label there. The y-axis label are going to be tons per hectare. The title is Nigeria Key Crop Yields, and then the all-important caption where you label your source, and then he does this /n there, this \n, which is telling ggplot2, okay, now in a new line, put this text here. And so this is going to be graphics by Mr. Ochiwar. So now he's got his the source, and then he's got a little bit of a watermark saying, I made this. So hopefully nobody can steal this. Sets it. So as you can see here, when you first print it out, it automatically tries to decide the best way to show the years. But but it was decided he actually wanted to define the breaks himself. So the breaks are going to be from 1961 to 2018. Every 9 years, draw in the year. So it'll be 1961, then 1970, then 1979, then so just progressing forward. That's an interesting way to do it. I typically like to do it by the decade, just because that's the way a lot of people like to think about years as decade or every 5 years or so. But
the other thing with this line here that you should note is he uses scale x discrete. If he kept year as a numeric value, you'd probably have to use scale x continuous to make it work. Because you can't pass if you use scale x continuous here, it'll kick out an error that basically says you can't pass a continuous scale to a discrete variable.
Yeah.
And it gets kind of cranky.
Yeah. So. But here you're saying, no, it's discrete because you converted it to factor. That's okay. Then he uses theme ipsum that's a theming from Harbor Master to define how he wants everything to look generally. It's got a lot of preset values here. But then he goes into this last theming here. So this is where he's going to fine tune a little bit of the themes that he wants to be using. So axis.title.y is element text size 10. So the the y-axis title is now going to be a little bit larger than normal at size 10. And now this really nice facet wrap. So facet wrapping is you pass a thing you want to be faceting by. This time it's crop productivity, which what is the crop that's being used. But if you remember back to the data set, if you look at P1, crop productivity is wheat _ tons per hectare. So this is where that really cool piece of code that he wrote comes into play. So he's faceting by crop productivity, and then he's going to add this labeler here. So what he's doing, he's saying, okay, run this function to get the what I want the labels to be looking like. And so this is like his homegrown version of we've used scales a lot, like scales ... percent or : percent when we wanted percentages to look very nicely. Here he created his own version for labeling how he wanted his facet wrap labels to be looking. And so what it's going to do is let's just run this.
Uh-oh.
Oh, I gotta run it from the beginning. There we go.
Yep.
Oh, what's going on here? This is not how it showed up earlier. But anyway, you can see now it's limited. So as we said, what that function does is it goes up to that first underscore and selects all the letters that are up there, and then it converts an all to upper score. And so this is what the labeler is doing here, is it's going through and subsetting out, so it's only showing the actual crop name, not the crop underscore tons per hectare. So this is a nice way to do it, so you don't have to actually do it inside of your pre-processing. It's just done right in your plot here.
Yeah, that's pretty cool. I've never seen. I wasn't even aware there was a labeler argument in the facet.
Neither was I.
I would have done this as a column. I would have mutated a column and done it. But so that's pretty cool.
Yeah, I would have done that too.
A nice time saver.
Yeah, so it's a sweet time saver, and I think it makes a really great plot. The plot itself is really great, and that little trick there, I saw that and I was like, I got to share this with everybody. I got to get this out, because I just thought it was the coolest thing.
Yeah, that's nice. I like that.
So thank you so much, Mr. Ochiwar, for letting us go through and explain your code, and teaching everybody this really cool trick that you used there. Cool. All right. So now we're going to continue our series on Shiny apps. And Patrick, do you wanna start us off on that while I kind of clean up some stuff over here?
Yeah, go ahead. Yeah. So last week we kind of started in a little intro to Shiny apps talking about reactivity, and we kind of gave we threw the idea out there that we would build on that by doing several series where we basically start from scratch and build a Shiny app over time, with each step along the way kind of showing you a new piece of Shiny apps. So this week, we're going to start our actual Shiny app, and we're going to take the data. We took the data from an old Kaggle competition, actually, that was on, I think it was like a machine learning in NBA or something like that. So the link will be within our R script, so you can pull the data yourself. The data will be available. You can take that stuff. The Shiny app that we're going to build is in some way inspired by the projects from 538, their Carmelo ranking board. And I absolutely love this. I think it's such a cool landing page for looking at players. So we can see on the left side, we've got kind of some info about the individual, some vitals in terms of height and weight, age, all that kind of stuff. Then we've got information about their actual play. So scoring information and ball handling information. And then on the right side of the page, we've got some kind of a cool look at the player over time. So their performance over time, how they've been trending essentially. And then below that, we've got a bunch of players that are of similar type of performance over time, let's say over their careers. So we thought we would take some of the concepts from this, because it is a really cool, clean looking page, into our own Shiny over time. So the first part we're going to work on this week is going to be that stuff on the left side of the page. That's basically kind of looking at the player's performance. So we're going to use that data from the Kaggle competition, and we'll pull that data in here in a second. We first load all of our packages. So we're going to use Tidyverse, Shiny. Patchwork we actually don't use. Neither did we use ggpubr or ggtext. I don't think we use ggtext. I kind of loaded those in with the idea that I thought I might need them. And
we might need them in the future one.
But maybe in the future. Yeah, we're not going to get rid of them yet. Let's just keep them there. We're going to set a theme. So this is kind of harking back to a Tidy explained, I think, 3 episodes ago, where the guy, 3 episodes ago?
I think it was Kelly Cotton.
Oh, Kelly Cotton. That's who it was. Yeah, it was a really cool theme set. Basically, you pick your theme, and then you define all the other elements of the theme that you want in there. And I can't remember who it was, but I thought it was an awesome idea. So I've totally stolen that, and I use it all the time now, and it works really well. So I set our theme up front as theme BW, and then some theme information there. So I define my axis text and title sizes. I'm going to remove the panel border from any plots, and then also the panel grid I'm going to want to be just gray color. And then I set up this custom function that we call percentile. And so if you remember from the Carmelo board, they have the actual observed stats, and then they have the little kind of dot plot that gives you the percentile. So I just create a little function to do that. So within that function, it's just going to take x, which is going to be an observed variable in a column, and it's going to create a quick little percentile for us.
And I did a quick check. It was Jared Braggins.
Jared Braggins.
24, episode 24.
Episode 24.
I wanted to make sure I got that correct.
Yeah.
We've seen great things from a lot of people.
Yeah.
I want to make sure
trick.
to attribute it.
Use it all the time. So there's our theme, our custom function. We're going to go ahead and we're going to grab the data. So the data will be in GitHub. Obviously, you can go to the Kaggle page and download it as well. We're going to filter out everything that's greater than year 2009 for right now. So we're going to create this stats data frame. There was a little row index. We just get rid of that. It came in as column X, so we'll just delete that. We're grouping by player and year. And then we're going to take the positions. So the positions are going to be within that year. And we've done this before when we've done some NBA basketball reference web scraping data. We're just going to take the positions and we're going to paste any unique position. So if a player played multiple positions in a year, we're just going to paste those into a column. And the same thing for teams if the players, let's say, bounced around on a few teams, so that we get all that information in one column. And then across is basically saying, okay, within the year and for that player, across each of those columns, we're just going to sum the data up. And any NAs are going to be removed from the sum equation. So we'll pull that data in. And we also pull in what we call vitals, which is like height, weight, birth year, birth country, all that kind of stuff. We don't use that yet for this one. We'll probably try and work it in some way.
Yeah, we'll probably create in the next episode or two the a player summary like what the like 538 has.
Yeah. So we'll primarily be working with the stats data frame for this one. We're going to go down and we've got this NBA stats function where we're going to look at everything from only year 2015 to 2017. So on that Carmelo board, they used the previous 3 years. So that's what we're going to do. The data set only goes up to 2017. That must have been, the Kaggle contest must have been end of 2017 season or 2018, something like that. So we're going to go from 2015 to 2018. We'll filter everything between that. Now we're going to group by player. And we're, again, going to summarize across. But this time, instead of within the year, it's within the player. So we're taking their 3-year totals. I'm going to keep only players that played 1,000 minutes over the 3 years because those are going to be the ones that are interesting for us. And now we're going to do a bunch of mutating. So we're going to create some new variables. So the first variables that we're going to create are going to be some like game specific, so minutes per game.
MPG.
We're going to get some percent MPG. We're going to get some percentage type of data, so field goal percentage, 3-point percentage, and then we're going to create some per 48. You could create per 48. Some people create per 36. Some people create per 100 possessions. I'm not here to talk about which is better or worse. Create whatever you want. This is just our example. We're just giving you the tools. So we'll create some per 48s, and then we're going to do another across here. And this time, we're going to look at all of those variables that we just created, and we're going to put them on this percentile function.
Yeah. So one thing that I think that's pretty cool that we should touch on is the fact that here you're listing the specific columns you want to be dealing with, but here you're actually able to use the colon there to go everything between MPG and blocks per 48, run it across all of those. So there's
between and including.
Yes.
I think in Python it would probably be only between. It does something weird, but between and including here. Yeah.
So I thought that was cool. I wanted to bring that up.
Yeah. That's a great space saver as well.
As you can see.
Yeah, exactly. And then I run the percentile over that, and then I just ungroup because I don't want to keep that grouping. So now we are left with a nice little data set that gives us a whole slew of NBA stats for the player for the previous 3 NBA seasons, 2015, 2016, and 2017. Okay?
Yep.
And now we're ready to get into a little bit of our Shiny app. To do that, we create this helper function. So this is one of Ellis's helper function. It was something that I was just doing at every reactive within the Shiny app, so he just functionalized it.
Yeah, like let's make this easier. We're repeating ourselves a lot. So what this will do is we pass in our data set. So this is kind of trying to keep in line with the tidy piping methodology, where the first argument is data. Then we use triple dot notation there so that we don't have to get into a bunch of like R-lang and that sort of stuff, because we're not doing a lot of complicated stuff. So pass the column names you want to be keeping through triple dot notation, and we'll pass it down to select. So this will behave exactly like a normal select, like you would every other time. And then we're going to pass it into a pivot longer because we're taking it right now. The data set's wide. We want to make it long. And so this is what that'll do is it'll take all the columns that we have, rename take the column names and turn it into a column called variable, and then the values within that to a column values. And so this is just like, we were just doing it a lot. So like, rather than copy and pasting and doing this every time, let's just turn it into a little function. At least that's my philosophy. I think David Robinson said, like, if you write your code 3 times, turn it into a function. So, and then if
you answer the same question 3 times, write a blog.
Yeah, and then if you write about it 3 times in a blog, write a book.
Write a book, yeah, exactly.
Yeah, we'll see. We'll get there at some point. The TidyX book.
Exactly.
Alrighty.
Okay, UI.
Yeah, so we hop into the UI now, and so we're using fluid page. This is the same that we're doing before. This is like going, okay, fluid page, so it's gonna adjust its sizing based on how big the actual page is, so that it handles a lot of the background stuff for like mobile versus looking at it on your computer. It's going to handle a lot of that for us on the back end. So fluid page handles that. Then we have our sidebar panel, which is it's going to be a kind of a base shiny. It's going to be like a grayed out box on the left hand side of the shiny there, which is typically where you put a lot of the controls for your shiny app. So we're setting the width to be 3. We covered that last episode. So before it was a little bit wide. It was a width of 4. We bumped it back down to a width of 3, and so now it's 3/12, so a quarter of the width of the viewer page, as opposed to 4/12, which is a third. So we just wanted it a little bit smaller. We didn't need it to be really wide. Now we have the select input. So this is a select input, not a select dies input. So that's really important. There's a key distinction there. So this only allows us, this is an input that only allows you to select a single item at a time. So we have our input ID, which is the ID that we then reference inside of our server. That is going to be player. We're also going to add the label, which is going to be the string that's shown above the selector that's telling you information about what the selector is doing. So here we just wrote player again because that's what you're grabbing, the player. Next we define the choices, which are the total options that are allowed by the user. And because we're using the NBA stats data set, we're going to say, okay, take the unique players out of NBA stats. And those are the total number of options that are available. And we're going to, by default, so when the shiny first starts up, we're going to have pre-selected a player. So that's what the selected equals. And as we've done a lot of times, LeBron James, because he seems to be the number 1 player.
And he's from Cleveland.
So. Oh, yeah, you're from Cleveland. So,
yeah.
So we got some nostalgia there. So LeBron James be the player there. So this is our sidebar panel. And now we've got our main panel there. And the main panel is like the main area where you're going to be displaying. A lot of things are going to be manipulated in the main panel. And we've got 2 plot outputs there. We've got plot score and plot defense. So plot output ID. So this is how we define when we're outputting the data set in our server. Output $, this ID. So what the score and defensive plots are. And then because the way we ordered them, it's going to show plot score and then plot defense in that order. They're going to be stacked. There's a lot of UI that we can get into, and we're going to touch on some UI elements in the future. But when you order them in your Shiny app in your code like this, it's just going to automatically stack them one after the other, unless you get into really more fancy UI development. But we're not touching it on this episode. Cool. All right, so next we're going to hop into our server. So this is what's defining the behavior of our Shiny app. So before we've been defining, hey, this is what it's going to kind of generally look like. And here's where this is where you really write a lot of the R code and define its behavior. So there's a few ways you can go about doing this in organizing your thoughts. What I like to do is I like to create, if there's something where it might take some time, or there's something that you're going to be then using later on. And so sometimes you don't know this off the bat. But if you know that there's a piece, like a data set you're going to be reusing across other reactives, I like to put that inside its own reactive. So what we're going to be doing is we're going to be generating plots later on. And so we're going to be pulling out of NBA stats that same player multiple times. And so I like to put this into its own reactive so that that piece of code only has to be executed once. And so now whenever input player updates, it's going to update player stats, right? With NBA stats, that main data set that we generated, filtered down to only have that player. And this is going to keep it, so if this was like a long-running process, this then reduces the amount of time that's going to have to rerun that process. And so that's kind of what that's going on. And next we're going to start building a scoring stats output. Patrick, do you want to take us through this one?
Yeah, so scoring stats output is also going to be reactive because it's going to react to the player stats, which is reacting to what the user is doing. So within that reactive, we're going to call the data set. And remember, whenever you're working inside of these Shiny reactive components, it's not just a data set. It's almost like a function. It's like a data set that's malleable because the user is doing something to it, right? So we're going to say player stats, which is the data set that Ellis defined above, and we're going to put in the parentheses to make sure that we specify that it is behaving similar to a function. And then after that, this is pretty much our standard kind of tidyverse fare. The rename function is where we do all the renaming. So we're going to basically take the values and change them from, field goal percentage value to field goal percentage, 3-point percentage, free throw percentage, assists per 48. We do this, the pivot summarized function, which Ellis defined above before we started our user interface. So it's going to.
I'm going to create the.
Are you going to run it? Yeah.
Yeah. Filter player equals LeBron
James.
So let's just I do this while I'm developing, and then sometimes when I first run my Shiny app, I forget to add the parentheses back in, and it'll complain to me. But this is how I like to do it. So just so we get a look at what the pivot summarize values does. So first renaming.
Yep.
Still wide.
And then just like just like our TidyTuesday submission that we went over this week, we're spinning that into a long data frame, right? That's what that function did. It took dot data and then comma dot dot dot, the ellipse, right?
Mm-hmm.
And that was the select that we specified.
Yep.
Then we do a little mutate here. And so this is a clever trick, also kind of harking back to Mr. Ochuar's custom label TidyTuesday submission. We're actually going to do a little bit of this cleanup within here. So you can see that Ellis is using the gsub function. So we're going to do a little bit of reject expression type work here. So he's going to, within this expression, take everything that is at that second underscore. Well, everything before the first underscore he's going to keep. and then he's going to remove the value after the second underscore. And so the stat type is going to be either value, or the stat type is going to be the actual stat, field goal percentage, free throw percentage, three percentage, etc. The type is going to be either value or percentile. And we just want to specify those things because when we actually go to make the plots, we want some things showing as percents, and we want other things showing as actual integer values per 48 variables values. For example, you can see right there, we've got values that are percentage form, so they're going to obey normal percentage values going from 0 to 1, and then the things that are the value form, so assists per 48, those are going to be numeric, and then we have the percentile values, which are also in the in a numeric format, so not 0 to 1.
Yep.
Okay.
So then we've got this pivot wider here, because as you can see right now it's long. We actually want to go back to wide a little bit.
Yeah.
So this is the
back and forth.
Yeah, I mean that's pretty common. So we're going to be using stat ID calls, which is this, to be our ID column. The names from is type, so this is this here, and then values from is value. So it's going to spin this out so that we keep the column stat, but this time it's going to be unique values. We'll have two columns, value and percentile, and those are going to have the actual values in here. So we're going to spin that out so you can see what that looks like. And then we just do some final manipulations here. For example, we know that when we're converting this value here, the assists per 48 is just a value there, so we don't want to do anything. So we just want to keep it as that actual value there. So we'll do this case one, but these these field goal percent or free throw percents, we want to turn those into a nice looking percent. So we're going to use scales percent to perform that task. Then we're going to make the stat look a little bit prettier because we want to use the percent sign as opposed to the writing out PCT. So we do that manipulation there, or assists per 48, we use the slash there to make that look a little bit nicer. We're going to convert it into a factor, and it's going to be the reverse order of the order they appear in, because when we go to build our ggplot next, when you plot factors on the y-axis, it flips the order, so we want to like double flip it.
Flip it back.
Yeah, flip it backwards. And then if you look at the Carmelo app from 538, they color the points based on their percentile. I think we just picked some values that looked like that's kind of where the splits were, where percentile, if it's greater than 75, it's considered good. If it's less than 45, it's considered bad. And then if they're just like anywhere in between those two, it's average. And we're just that's how we built this case when. And then we're going to set the factor level to be that, and that's just going to help us out in the future. We've got that. We do the exact same process, which is why I wrote that function with the defensive statistics. So we probably actually could have turned this whole thing into a function to make it a little bit easier on ourselves. And then the last piece here, because there are no things that need to be scaled to percents or turned from percents to a character value, we're just able to do a round. We're making the TRB, what's that mean again?
Total rebounds per 48.
Oh, total rebounds, and then blocks per 48 and steals per 48. Same coloring here. So we've got two data sets now, two out of the two reactives. One's showing the scoring statistics and one's showing your defensive statistics. Mm-hmm. So we've got those built out over, and then we're gonna hop into our plot. So these are inside a render plot, and like all other reactives, it's going to be looking at scoring stats, and when scoring stats updates, it's going to then rerun any reactives that are inside the render plot. If they update, the plot's going to be updated again as well. So what's happening here? So this is a rather complicated ggplot. Same idea, once again, is copied by in defensive stat, because if you look at the Carmelo app, it's the same type of plot in table combination. So here we're actually going to manually create with ggplot the table, as well as the plot on the right of it. And a lot of this was actually inspired by Giorgio's plot that he created for the Tidy Tuesday on the Tour de France. So thank you, Georgios, for sharing your code, because this would not have been possible otherwise. So here, let me quickly make sure I have the scoring stats data set here. I'm going to do something you probably shouldn't do, but this is how I also create things if I'm being lazy. So now we've got scoring stats in our table like that, so I can now go through and start building our ggplot. Do you maybe want to take us through this first bit, Patrick?
Yeah, so we're going to use the scoring stats data frame that he just created. We're going to do create a new variable called stat_POS, which is basically taking the stat value that's currently there, which is we can see as a factor, and it's going to turn it into a numeric. And this is going to help us with the plot order, so we know where when you turn a factor into a numeric, it's basically just returning back to you the integer level of that factor. So in this case, assist for 48, because it starts with an A alphabetically, is factor 1. Okay, so we create that new variable, and then we start a ggplot here. So we start ggplot theme void to get rid of what we had, voided out. And then theme legend position equals none, because we're not going to use the legend for right now. And then we start with geom text. So this is a unique kind of ggplot, because it's not initially going to be like a data figure. It's actually text. It's actually going to be word. So if you remember the Carmelo page, it's going to be like free throw percentage and then some sort of value. Yeah, exactly. So it's a plot, but it's a table, but it's a plot.
Yeah,
right?
It's a little complicated to put this together.
Yeah, it's a little complicated. So we have got geom text rather here. The AES is y equals 0.1, x y equals 0.1, and y equals stat position label stat. So we're going to label the stat value, right? The y variable is the stat_POS, which is the numeric factor variable that we use. So that's going to help us line it up. And then the x at 0.1, and this is because of how you had to break apart the grid, right? Like in order to create this, in order to create the two plots lying next to each other and have them lined up, you essentially had to create a grid, right?
Yep.
Exactly.
Yeah, and then h_0 is going to left align them with our x-axis of x.1. So all the stat labels are going to be appearing at 0.1,
yep,
going out to the right. So it's
yep,
going to look like your standard table.
Yep.
And this is same idea, but this time he's using the actual statistical values that we generated as well. And this time they're going to be right aligned, so h just is 1, but they're going to be drawn at x equals 1.9. So we can quickly run this and see what this will look like. So it doesn't look like a very pretty ggplot right now, does it? It's just like, hey, we've got these stats and these values here. And that's left aligned, that's right aligned. And so now we're going to make it look like a table. So that like what it looks like on 538. So first we're going to start drawing some vertical lines here. And so this is like geom segment. Annotate is a fancy way to do this. You could do this
super
with
helpful function. We've used it in the past to annotate text onto plots. So in this case, the first argument there that you're giving it is you're telling it what kind of geom you want. So when we've done it with text, it'd be quote text. In this case, you're using segment because you want the actual line segment to be drawn for the specified x and y value.
Yep. So right now it's gonna draw a bunch of vertical lines where x is either 0, 1, 2, 2.5, and 4.25, and x ends, so where it ends is going to be at also at the same positions. So because we don't want the lines to be slanted. And then the vertical, how far they'll go vertically, is y equals 0.5 to y equals 4.5. So let's draw that so you can take a quick look at what that looks. And these are just the vertical lines that'll be appearing on our plot. Next, we get into the horizontal lines. And this is slightly, I had to think about this a little bit more, but essentially what it's doing is we're going to be drawing a line. Here, let's move that out so it looks a little bit prettier. So what we want to do is we want to draw a line between this point here and this point here, which is why it was valuable to have the stat pause variable, because we know that this right here is at 1. And so we want to draw a line above and below it. So 0.5 and 1.5, we'll draw it right below it and right above it. And we're going to have 1 unit spacing between all those. So this is a horizontal line now between this point here and this point here. And that's what this is doing. And then we're also, this is going to be our point plot that is in the 538. And so we're also going to be drawing lines there too. We didn't want to draw any lines in between these two here, which is why we have 2 different segments there. And now we're actually going to put in the vertical lines for the plot as well. So we're building this all manually. This is not like a standard.
Yeah. This is like a truly cobbled together.
Yeah. So we're going to draw 2 lines. So this is at 2.25 and this is at 4.25. And so the distance between this and this is 2 units. And so if we want to draw two lines at the 0.25 and the 0.75 percentiles, we need to draw them at 2.75 and 3.75 on this plot. We're also going to draw a thicker vertical line at the 50th percentile. And so that's what 3.25 is 50% between this line and this line. And then we're going to label that with 50. So the x position is 3.25, which is the same as that line there. And then we're going to draw it at y equals 4.7. So this is a pretty new concept, I guess, from what we've covered before. But let's run that. So now we go. So now we've got our table on the left-hand side and what will be the plotting canvas.
Yeah. The reason we had to do this is because originally I had tried one where I was using like GG text table and GG plot together and tried to patchwork them, and it looks okay. You can get them lined up and they look pretty nice inside of the little console window there. The second you go to something like Shiny, where different web browsers are different sizes and it starts to stretch, things get haywire pretty quick. So we had to actually cobble this together by explicitly defining where we wanted things organized on the page.
Yeah, and this is to make sure it looks nice. And then now we're actually going to get to drawing those points. So we have the points here. So these are the points that we're going to be now drawing for our GG plot. And this is now using something we're familiar with, geom point. So we know this one. But here we need to scale it down so it fits on our little canvas here. And so we know percentiles out of 100. So we're going to divide it by 50 because the distance between this point here and this point here is 2. And then we also want to start them at 2.25. So this is what this is going to be doing. So now it's going to be drawing a point between here and here based off of the value that they have. And then y is stat pause. So this way it's lined up with the specific statistic that it has as well. So that was another reason why we had to build this up ourselves, was trying to get everything to line up was a little bit frustrating. This fill is going to be set by color. And so if you remember, color was either bad, good, or average. And we're gonna set the shape to be 21, which is an empty circle, where color defines the outer color, and then fill defines the inner color of that circle. So that the color is black, so it's going to be a black circle filled with whatever, whether it's good, bad, or average. But we wanted it to be a color that we defined, right? Because by default, it's going to be using the ggplot2 colors. We didn't want that. So we wanted, if it's bad, color it red. It's not good. If it's average, color it white. It's a neutral color. And then if it's good, color it blue. which was the color scheme that they used in the 538. Finally, we're just going to add some titles around this, because as you can see, like if you just look at this plot, you can't see, oh, what is this and what does this plot show? And so we're now using geom text at this point too to define. All right, so our data is going to be a data frame. The labels are going to be shooting statistics and shooting percentile. The x-axis, so we're going to left align them with the table in the plot, and so x is 0, and or x is 2.25, which is right here, and then y equals 5. So vertically, it's going to be up at 5. So this is 4, 3, 2, and 1. So it'll show up right around here. And the h just is 0, so that way it's left aligned. Otherwise, I think it's centered around it. And then size equals 10 to make that plot a little bit larger. So let's run that and let's zoom it so that it looks nice for us. So this is LeBron James, or what would be LeBron James table on the Carmelo app. So as you can see, everything's lined up really nicely. It's all appearing the way we'd expect it to. But we've got it set up so any data that's going into this, it'll update this in our Shiny app with their values. We do the exact same thing with the defensive plot. I'm not going to spend the time to go through that because it is literally copy code.
With the exception of the fact that there's only 3 defensive variables. So there is a little bit of change to the y values, the y starts and ends in all those annotates. But other than that, same thing.
Yeah, exactly the same thing. So now we're going to start our server. So let's run everything. And did I save it? Is it going to run? Nope, I forgot
you took out your reactive.
Yeah.
In the stats thing, scoring stats.
Here.
There it is.
See, that's why it always bites me. But for me, it's easier to develop that way.
Yeah.
What? Here.
Another one. They bit you twice. 3 times the charm. Yeah, here we go.
There we go.
Hey.
So as you can see, this is the same exact plot that we just showed. Here's LeBron's defensive statistics and percentiles. So you can see all except for free throw percentages. Apparently, he's pretty good at.
And then it's totally reactive to whatever the user does. So you can select names, or you could even start typing. You know, if you wanted to start typing, I don't know, pick a player. 2017 was
Splash Bros. Why am I?
Dwayne Wade. Yeah, sure. There you go. Klay Thompson.
Go Cougs.
Yeah, that's right.
Yeah, free throw, high free throw, field goal, 3-point.
Exceptional 3-point percentage. Not much on the defensive side, though.
But he wasn't known for that. So
the one thing I would say is, and we didn't use the variable turnovers per 48. But I will say, if you were going to use turnovers per 48, if you look at all the stats that what do we have? 4 shootings. We have 7 stats. If you look at all those stats, the higher value that you get, the better. The better you would think the player is a better player, right? More rebounds per 48, more blocks per 48, more turnovers. The more that you get is the negative. So that's the only thing is when you do something like this, always just be aware that if the value that you're including in your plot is higher means worse, you got to flip the percentiles. Otherwise, it'll drive people crazy to look at.
They'll be like, what do you mean it's worse? He only had 2 turnovers per game. That's supposed to be good. I don't know if that's good or not. But.
Yeah, exactly. I don't know. Yeah. But, yeah, turnovers per 48 or something like that.
Yeah.
But exactly. So just make sure you might want to flip those. But other than that, yeah, it's a pretty cool app. And I think the next episode we'll try and build on that, maybe with some tab sets and some line plots. And then we'll get into a few other things in the subsequent episodes. But this is a initial start, at least. Yeah,
so now we've got some stuff together. We've got some plots, got some concepts together with how to order your reactives to make sure you're not reproducing a lot of work. And hopefully this is valuable to you. Please let us know in the comments. Tag us on Twitter if you think if this was helpful as well. We love seeing that on Twitter. And with that, I think we'll call it from here. So as always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. You can find me on Twitter at OSPPatrick. Both of us are on Twitter at Tidy_explained. And with questions, comments, etc., you can hit us up either on the videos or on Twitter, or you can email us at tidy.explained@gmail.com.
All right. Thank you very much, and keep on exploring your world.